What up? It's time for Advent Code Day 3. Here's part 1. Buy a rental shop, multiply some numbers. However, this part has been corrupted. There. Ooh. You're going to look. It should be ignored in sequences like mole, do nothing. For example, following section of. Okay. It does instructions like mul xy, xy, each 1 and 3 digit numbers. Yep. There are also many invalid characters that should be ignored, even if they look like part of the mul instruction. So all of these do nothing. Adding up the result of each instruction produces 161. What do you get if you add up all the results of the multiplications? So, save our input. .txt. Save. And let's move downloads input.txt to here. Come over here and parse our input. We have f.read will give us just the entire input text. Let's see. What does make it valid? So there needs to be no spaces. Needs to be do not mul 55. What's wrong with do not mul 55? Oh, that's fine. So I think what we should do is we should just look for every instance of mul in the text, right? So let's say muls equals I for I in range length of input text only if the input text from I up to I plus 4 equals mul, like that. And then let's print muls and see, and let's also print mul 0 input text of from muls 0 up to muls 0 plus 10, just to see like what it shows us. Let's do that. This should be brackets. And we got mul 26862 and a bunch of indices where there's possible muls. So now to see if it's valid, let's take this index and let's go to, so it has to be a 1 to 3 digit number. That should follow. Then a comma, then another bracket after. So let's find the next closed parenthesis after. And if it has a length that's too large, then we'll do it. All right, so let's go for I in muls. What's the largest it could be? 2 3-digit numbers. If I plus, so it'll be 1 2 3 4 5 6 7 8. So let's take the text from the open paren, which would be moles minus 1. No, it'll just be from I plus M, let's just say 4, I plus 4, up to the closed paren, and this should give us the two numbers. And so we'll split it by comma. And then if length of nums is not equal to, or from strings import star, I'm going to continue. Actually, let's change this. Let's use 4 else. So we're going to go up here. We're going to go to, I'm going to say I plus 8. And then if input text of close paren equals a closed parenthesis, then we're going to break. Why is it messing up? Come on. We're going to break. Else we're going to continue like that. Now we know for sure it's a closed paren. So if you look at our nums, if length of nums is not 2, we're going to continue. And then we're going to say num1, num2 equals nums. And if any char in num1 plus num2, if any char for char in num1 plus num2 is in ASCII digits, we're gonna continue as well. So now we're gonna, if length of num1 is greater than 3, or length of, so if length of if it's not in the correct length bounds, then we're going to continue that. This in ASCII digits should be over here. And let's go to F2 and let's D till there, just like that. Go up 18, find this S and delete it. Okay, ASCII digits like that. Otherwise, we're gonna say prod total plus equals into num1 times into num2, just like that. gonna print total. Go up 15. Total equals 0. Does this do everything? Well, first of all, let's just try it and see what it says. Might mess up. Yeah. Nums equals input text like that. ASCII, is this not defined? I think it is. Mul 268 to, let's see, total let's get num 1, num 2, Mul 268 like that. Let's delete this part. Okay, I got 0, something's wrong. So what are we doing here? We're finding each mul, we're taking the total to here, nums input text. Let's print nums and see what it shows us. So I got 80 here. Does that make sense? What does my input look like, right? First mul should be 268, 621. Where's the 80 coming from? So maybe it's overshooting. Something still seems wrong, but let's try that out, right? 0, 0 plus 1, 0, 1, 2, 3, 4. Close for an I plus 8. If input text break, otherwise we continue. I plus 4 up to close paren dot split by this. Let's also just print input text from I plus 4 to close paren. $80, that's nice. How about just I? Mul 80. I see another mul right here. And another mul right here. Why is it the first one? Let's print moles again. We got 6 right here. 6. Ah, I see. We should be searching after the close paren, right? So instead of from I, we should be looking at plus 5 and then 13. Should probably just be using regex for this, but I hate regex. 268, 621. Nice. ASCII digits is not defined. When in Rome. Nice. All right. So let's delete this. Let's delete this. Delete this up here. Still getting 0. It doesn't seem right. Let's just say not. Nice. Let's try this out. Right answer. As you scan through the corrupted memory, you notice that some of the conditional statements are also still intact. Recent do or don't instruction applies. At the beginning of the program, all instructions are enabled. Don't. Do. Before the other mole instructions function normally, including the one at the end that gets re-enabled by do instruction. So it says don't. Do. It's 48. What do you do if you add of just the enabled multiplications? Aha, okay. So now we need to be a little bit more careful. We need to say, so now what I'm going to do instead is I'm going to just go through the input text sort of sequentially, right? Let's undo all of that. So I'm just going to take all this, right? And I'm going to go down like that, yank it. And put it like that. And I'm going to save this code for later. I don't want to deal with it, right? I'm going to go just like that. Nice. All right. So now down here, what we're going to do is we're going to say, we're just going to go through the input text manually, and we're going to use a stack, right? So we're going to say for I in range, for char in range, length in, oh my gosh, for I char in enumerate input text, and then we're going to say stack equals this. Man, this is gonna be hard. Let's do equals. Let's keep using our old code. Let's not rewrite everything, right? What we're going to do instead is we're just going to count the number of do's and don'ts between indices. And if there's a don't, then we're not going to add it, right? So in between these, let's say for I and moles, what we should do is we should be looking at prev I in pairwise. Chain 0 moles, just like that. And so now we're going to say do equals true, and then for I in range, prev to I, if input text of I to I plus 2 equals, I should say I plus, how many characters is this? Is don't. It's 5, right? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. We're gonna cheat. Yep. I think do would be 4, right? Yep. And now all we have to do is, when we're adding down here, we make sure that we say do times this right here. And see how that goes. I get 0. Something's obviously wrong there. Prev and I. Chain 0 and moles. Do and don't. I and I plus 7. I and I plus 4. Does this sound correct? So if I'm here, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Yeah. It just falls forever? Oh, it's not even... Oh, it's not even getting to here. It's getting there. So is something here getting messed up? Ah, right here, the I is getting messed up. I'm overwriting it. Let's just rename it to something else. Just like that. Nice. All right. I'm gonna need to clean this up like crazy. All right, so a quick rundown of what I actually did. For part 1, we're given a list of characters which represent instructions. They looked like this. And what we're told is that we're supposed to do a series of multiplications. Multiplications can consist of 1 to 3 digit numbers. So we take every valid multiplication and add them all up. And they're invalid if they have invalid characters in them or consist of other multiplications and such. So it's not recursive. So what I did for this is I just treated the input as one big string. And then I found the index, so the position of every substring, which looked like it could be a multiplication operation. Then For each of these positions, I looked for the next closing parenthesis. Because a number could only be, each argument can only be up to 3 digits, the closing parenthesis can't be more than 13 away from the initial m. And so those are the only indices I'd look at. I break if I find it, and in Python, if you don't break from a for loop, then the else condition executes. And so in this case, if we don't find the closing parentheses close enough, then we know it's not a valid multiplication operation, and we just continue to the next possible candidate. If it is possibly a valid operation, we try to extract the nums from it. So basically, we take the character after this closing parenthesis, after this opening parenthesis, and up to the closing parenthesis that we just linearly searched for, and then we split by a comma. So if there isn't a comma, the split won't work properly, and we only get like one element in our list. So that's what we check for here, right? If the correct number of commas is there, the length of our split should be exactly 2. So if it's not, we skip it with the next candidate. Then we take our 2 candidate numbers, and if they're not the correct number of digits, or they're not even consisting of ASCII digits, then we skip this multiplication operation because it's invalid. And if it satisfies all these constraints, then we finally convert them into integers, and we add it to our total. For part 2, they introduce this sort of enabling and disabling feature. And so there's a do and a don't function. And it's forgetful, right? So it doesn't even matter if there was 3 do's and then a don't. If there's a don't right before a mul, then we can't do the mul. And so now we should only add up the ones where the feature is enabled. So we take our old code and we treat it pretty similarly. The only difference that we make is that between our candidates, so I look at our candidates in pairs, right? So instead of just looking at candidate 1, doing all this stuff, candidate 2, what I do here is I look at candidate 1 and candidate 2, or candidate 2 and candidate 3, and so on in our muls list. So it's important to make sure that we don't neglect the indices in the beginning of the string that are before the first candidate multiplication operation, because it's possible that they contain a don't and that we shouldn't count that one. So the way that I made sure to count those indices was that I prepended a 0 to our candidate indices, so that way when we do this first scan, we're actually looking at the indices from the beginning of the string up to the first candidate multiplication. So that's what this chain does, right? It takes this iterable and this iterable. Chain takes in arguments of iterables and it iterates through all of them as if they're one big iterable. And so instead of copying the input text instead of copying the candidate multiplications, but at prepending a 0, I just made a new list with a 0 and then continue to the existing list. And I just linearly scan through it to see the do and don't operations. And so if I see a don't operation, I set do to false. And if I see a do operation, I set it to true. And then otherwise, we do the same thing. And then when we go to add our total, then we multiply it by do or don't, right? And really, what we could do here, if we wanted to, is we could say if do is false, so if not do, we can just continue as well, right? And this should still work. Like, let's try this out right here. We get the same number, right? So we could have skipped some work, but in this case, it doesn't matter too much because this work is very small. We're only looking at like 13 characters, right? But if multiplications got very big, it might be worth making this optimization right here. But yeah, that's Happy Code Day 3. Thanks for watching. I'll make sure to post solutions on GitHub. And if you want to join me in doing daily LeetCode problems, seeing solutions posted by me and others, come join my Discord. Have a good one.